One of the things you have learned how to do is to collect data and make good measurements. We know that data is going to end up being in two forms. One where you observe and see and smell and hear things. And of course you write those down. They provide us with things. But also we have to make accurate measurements. Now, we normally refer to data as the measurement things. And as we can see here, it can take on a whole variety of different forms. Now, one of the biggest problems you have when you're planning your activity is thinking about, am I using the best equipment for the job? For example, you might be looking at something to do with volumes of water or volumes of a liquid. So we know we've got these things. We've got a beaker and it's got marks up the side, and we've got a measuring cylinder. It's also got lines up the side to help us work out what's going on. They are both specific in what they should be used for. Now, I would never encourage you to use a beaker for measurement. There is too much of a distance. Look, there's between that line and that line, there is 100 difference. So if we put water or some other liquid in there, we are going to be guessing about the value of liquid we have in there, or the volume we have. In this one though, we've got lots more marks, and in this one I have in front of me, we've got a situation where we've got, there's 15, there's 20, and we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 marks there between 15 and 20. So that means each mark corresponds to half a cm cubed of, or half an ml of liquid. Much more accurate, and we can use this to actually create some precise data. So always try to use something that is going to be the best for our measurement. Now, as I've said down the bottom here, the number of marks between these things. So between here and here, we know we have between 100 and 500 cm cubes. And that means each of the marks is 100 cm cubes apart. So it's a huge amount of water or liquid we could have between it. And over here, we have half a cm cube between these. So our chances of getting a more accurate reading are much higher using this than this. Okay, some things we normally use in the lab to do this. Right, here is our measuring cylinder again, and in this case we can see there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 between 70 and 80. So that means each one of these lines must be 1 cm cubed different. So when we're recording this data using this piece of equipment, right, then we have to record the whole numbers. If we sort of say it's somewhere between 70 and let's say 71, the line above, then we're guessing of how close that is. Right, so we've got to stay to the mark. The actual equipment we use should tell us how accurate we have to be and how many decimal places we have to record. So if I was using this measuring cylinder, I would be recording the whole numbers. Now let's have a look at this one over here. This is a smaller one. And between 4 and 6, we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we've got 10 lines between, which is the difference between 4 and 6, which is in 2 mLs or 2 cm cubes. So that means each one of these lines is 0.2 of a mil. So we are now recording to 1 decimal place here. So let's say if we look at this one, we've got 6, 0.2, 0.4, 0.6, 0.8, 7, 7.2. and the bottom of the meniscus on 7.2. So I'd be recording that as 7.2, not 7, but 7.2. So you should record, if you're using this one, you would record to 1 decimal place. Right, we've also shown you how to use the electronic balances. Now the reading on this, I've got a beaker of some description sitting on here, and it says that the mass is 46.42 grams. So there's tenths of a gram. Here is hundredths of a gram. So we're measuring to hundredths of a gram. So we don't just throw away measurements. So if we record this was 46.42, but what would happen if it was 46.00? What should we write? Well, I would be suggesting you would write 46.00, not just 46. All right, try to keep things consistently. You'll see how this is telling us how many decimal places to write. So we will use 2 decimal places. Now, up the top here, we have a force meter or a spring balance. And we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. On this side in newtons, there are 10 there. So we're measuring 1/10 of a newton. So that would be 0.1. Again, this would allow us to write down 0.1, or use 1 decimal place to talk about the number of newtons we used in our experiment. Right. Here is an old-fashioned thermometer. Now this one has got, again, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, between 1 and 2. Right? So if I'm doing that one and seeing what's going on here, each one of these corresponds to, I think that's actually 10 to 20. So each one of these corresponds to 1 degrees C. So the maximum number of decimal places I can use is 0. So we're using whole numbers again. And the last one, it may not be exactly the same one you use, is a stopwatch. In this case, we've got seconds and then parts of a second. All right, so we are measuring within multiple decimal places. Might I suggest you that one? And these two might be significant. So we might be measuring again to 2 decimal places. So, to cap it off, in general, choose the equipment that's best for making the measurements you want to make. If you're measuring volumes, use a measuring cylinder. If you're using masses, use a electronic balance. Right? So anything you're using, try to make the best of it. Now, sometimes your teacher will help you out with that and say to you, perhaps you need to use a data logger. Now, data loggers tend to record to 2 decimal places, so we should show our numbers as 2 decimal places. And that is the reason why we have the second point, which says that choose the equipment that gives you the most accuracy. So I would be suggesting to you that if we have got something which is accurate to 0.1 of a gram or whatever, then that is more accurate than something that is going to be only 10 grams different for each different one of your marks. Okay, so hopefully that makes it a bit clearer. Now let's look at how we're going to present our numbers in our next video.